Welcome to Topic 3 of the Information Systems project. Topic 3 is about systems development, and we'll be using this topic to discuss a number of methods for systems development. You'll be developing a system as part of your project, so it's important to understand the different approaches that can be applied to that development. We'll also be discussing some of the features of the project and therefore enabling you to choose a development methodology that is appropriate for this type of project. Last topic we discussed a number of things. We discussed the reasons for selecting a particular project, and you will have done some exercises in order to help you choose which project you would like to complete. We also looked at the purpose of the projects in terms of academic projects as well as in terms of meeting your own personal goals, and you had a chance to analyse some projects using SWOT analysis. You also analysed yourselves using SWOT analysis, and hopefully with the results of those analyses you should be able to choose an appropriate project and one in which you can achieve. So using the results of those analyses you would have been able to make a decision about which particular project you're going to go ahead with, and hopefully at this point you'll know what it is you're going to do for the rest of the project module. So in this topic we're going to cover various systems development methodologies, and we're going to look at systems development as it applies to your particular project, and then by the end of this topic you should be able to choose a particular methodology in order to complete your project. So by the end of this topic you should be able to make an informed choice of system development methodology, and you should understand some of the techniques that can be applied to systems development. There are many methodologies for developing systems, and most of these have been designed with a specific purpose in mind. Usually those purposes will be in order to satisfy a customer need quickly, on time, and to fulfill a customer's requirements. So most of the development methodologies that you see will be developed having clients in mind and real systems in mind. They're not designed for academic projects. So often when you try and apply a systems development method to an academic project, there sometimes is a little bit of a problem in making the method fit the purposes of the project. This is a similar issue to that of industrial projects versus academic projects as discussed in the previous topic. So as I've said, most of the methodologies that we come across have been developed with a specific purpose in mind. Sometimes that might be to reduce the amount of risk in a project, sometimes that might be to ensure that the customer's specifications are met, or sometimes it's to ensure that changes in the specification can be included in the project. So one of your aspects of your project might be to investigate one of these methods and to see how it can be applied and to understand it better. Certainly during your project you'll be applying a method, and I will talk to you a little bit about how to choose a method and which methods might be appropriate for such a project as you're carrying out. There is often a debate about methods or methodologies, and when you read books about systems development methods you'll often see a little section saying what is a method and what is a methodology. Mostly I'm not too worried about this. I think we can get overworked up about words. Mainly if you're consistent with your terminology, then that will be fine. So don't worry too much about the difference between a method and a methodology. So the following I've listed as methods. They will be listed various places as methodologies, and it really, as I said, depends on how you want to use the word. The most common method for software development is listed at the top here, the waterfall model. It's a traditional model. It's been used since the 70s, maybe even before that, and it's attributed to a gentleman called Royce, although actually it was developed earlier than that for large systems. The waterfall model we'll discuss in far more detail on the next slide. The second model listed here is called the spiral model, and again it's very popular in academic texts, and I'm not sure how often it's been implemented fully, but it is a precursor to many of the modern agile methods that we'll talk briefly about. Spiral model breaks a system down into a series of increments, and for each increment it goes through 4 main stages. So the next on the list is incremental development. Incremental development, I've already mentioned the notion of increments. Incremental development breaks down a project into a small number of pieces and then carries out the full system's life cycle on each of those pieces in turn, adding more functionality for each increment or each time around the development life cycle. Typically, each increment in incremental development will use the waterfall model, so it will go through the same set of stages as the waterfall model, but for smaller parts of the project. Evolutionary development is slightly different from incremental development. It does break the project down into iterations, a series of times through the development life cycle, but each time it builds extra functionality onto the existing system rather than having broken it down into smaller sub-projects. And evolutionary development is often linked with the notion of prototyping, where we create a prototype of the system first and then gradually add functionality until we've got a complete final working system. Prototyping itself is an approach on its own, and it's often used where we're dealing with experimental systems that we've never developed before, or technologies that we've never developed before. This may sound familiar to you because it may be, actually, it's very likely to be, the approach that you're looking at for your information systems project. If you're using technologies that you've never used before, or you're using a development approach you've not used before, or languages, or developing a system that you've never done before, then prototyping is usually a good way of doing it. So the waterfall model is presented here. This is the standard diagram these days taken from Wikipedia, and you'll see there's lots of other diagrams on the internet that look very similar. Some of them have slightly different labels on the stages, some of them have more stages, some of them have fewer stages, but basically the waterfall model looks like this, and I'll talk you through what happens at each stage as we go through. So it's called the waterfall because information flows down through each stage, and the theory is for this model is that you complete each stage before moving on to the next. So you would complete the requirements before you move on to the design. When you finish the design, you can then move to implementation. When you've finished implementation, you can move on to verification or testing, and when you finish testing, then you can move on to the maintenance phase. And in some cycles it moves back from maintenance back to requirements. The idea being that after you've maintained a system for so long, it loses the ability to actually function, starts to fall apart, starts to become a bit of a mess, and needs actual total redesign and redevelopment from the requirement stage. So sometimes you'll see a loop from maintenance back to requirements. The requirements stage then deals with gathering information about what it is that you're going to develop. It doesn't really look at how you're going to develop, although it may deal with some information about the system that is going to be implemented on. So are we going to have a system that's built around the use of the World Wide Web for a database? If so, then that might change some of the requirements. Are we going to have a local system that only one user is using? Again, that may be part of the requirements and may affect some of the implementation later on. But primarily the requirements is about what the system will do, and one of the best ways of dealing with requirements is using a technique called use cases, which we'll discuss later on. So when we know what we're going to develop, we've spent some time carrying out some requirements analysis, we know what we're going to do. Now we need to make sure that it actually fits onto the technology that we're going to build it on. So we start to design, and design primarily has four elements. There's user interface design, which is what most students think of when we're dealing with design. This is what the system will look like, and it's quite an important aspect of design, but it's only one part of design. Something that's very important for information systems is data design. Okay, you'll design your data for your database, and you'll design the queries that allow you to transform that data into information, and those queries will be presented on forms, and those forms are part of the interface design. I've mentioned queries already, transforming data into information, and that represents what we would call algorithm design. That's the third part of design. And then the fourth part of design is architecture design. Again, with an information system, some of that decision making about architecture is taken away from us, because we're using a database, usually with some sort of front end that may be a web front end, or it may be a standalone front end with Windows Forms. Either way, it's very similar, and the architecture is a database architecture. So there are four parts of design. There's interface design, architecture design, algorithm design, and data design. And they're all very important, all interlinked, and it's important to get them all right in order to satisfy the client. Okay, from design we move to the implementation phase. We've designed our system, we know what the user interface is going to look like, we know what the data is going to look like, we know which algorithms we need to transform the data into information, and we know the overall architecture of the system. So now the requirement is that we build the system. And we can make various choices about the implementation, but many of those will be driven by the requirements in the design stages. So the fact that we're implementing on a database has already been decided by the architectural design in the design phase. So our implementation is how do we actually create the data tables, and how do we actually write the queries. And we'll also be implementing user interface. And again, there are choices. We may use a tool to develop our interface for us, or we may code our user interface from scratch. Okay, but implementation should be pretty straightforward. We've designed the system, now we just have to implement what we've designed. On another note, we can also get code generator that will do some of the implementation for us, so which is quite handy, and as time goes on we'll see more and more of this in systems development. So as far as the waterfall model is concerned, once we've implemented the system, we then have to test it to verify that it is actually working. Now, verification isn't the best word there, but as I've said, you'll see it on many models because they're all taken from the model in Wikipedia. Testing actually includes two parts. One is verification and the other one is validation. Verification verifies that our system works, that it does what we've said it will do, but validation actually checks to see whether the system is doing the right thing. So whereas verification is really testing against the design and implementation, validation is really testing against the requirements. Does it actually meet the needs of the client who's asked for it in the first place? So we can verify our system, and we may verify that it is correct, it does work, but we also have to validate that even though it works, it is working in the way that the client wants it to. So whilst you'll see verification here labelled in the testing stage, I would prefer the word testing, and remember that verification and validation are part of the testing stage. It's also worth noting at this point that during implementation we will carry out some testing as we build the system. We'll build one module and then we'll need to test it to make sure it works before we actually build any more. So testing has already been carried out as part of the implementation phase. And arguably as part of the design phase too. We'll test our designs, we'll ask somebody to look at them, we'll verify that they are actually correct and validate them and make sure they meet the requirements. So in the waterfall model, verification and testing is carried out after implementation, but in reality it occurs throughout the waterfall life cycle. So once we've got a system that's working, we will then implement it at our client's system. So that's generally known as commissioning. And this moves us into the maintenance phase. Maintenance performs two main activities. During the testing phase, we can never actually find all the problems with the system and correct them all. And it's only during normal usage that we actually find many of the errors. So the maintenance phase involves some time spent recording those errors, getting information from the users and fixing them. and this should be part of the development process. This is part of the contract that we will have agreed with our clients as we develop this software. So if we find errors in the system, we have to correct them, and we have to do it as part of the implementation of the system, as part of the same contract. The other thing that happens during maintenance is that the client may ask us to extend the system. So we want to, if this is a likely occurrence, then we want to design the system for extension so that we can extend it. So two parts of the maintenance stage: testing and correction of errors, and also creation of new functionality, addition of new functionality. The maintenance stage, as far as your project is concerned, will include future work. You will be expected to write a section in your report about future work, and that's really what would be covered in the maintenance stage as additional functionality. So bear that in mind as you go through from the requirements through to the implementation stages, that there may be functionality that you want to add later on, which you won't add for this project, but is a useful discussion for future work. If you want to have a look at the waterfall model in more detail, then you can use the link below to the Wikipedia website, or you can actually do a Google search, and you'll find a lot of different versions and a lot of discussion about what goes on at each stage. Okay, so we've just looked at the waterfall model as an approach, and I'd suggest you have a look at some of the other approaches to systems development as well, such as the spiral model. You should be aware of what it does. Whilst I don't believe any of you will actually use it, although, as I've said, you may decide that that's what you want to do as part of your project, to investigate that approach. I think it's definitely worth looking at, and you will learn something from developing an understanding of it. And we've also looked at evolutionary and incremental approaches, as well as the prototyping approach. Within each of those approaches, each of those methods or methodologies, we can choose a number of options for how we actually build our system. And I've described these as techniques, and there's two main options here. The first is a more traditional approach called structured development. Structured development makes use of tools such as entity relationship diagrams, data flow diagrams, and a number of other tools that have often been incorporated into a methodology called SSADM, or Structured Systems Analysis and Design Methodology. SSADM is famous for its use of structured development. It's also famous for creating a large amount of documentation and being very slow for systems development. But the amount of documentation that it created was also one of its advantages, in that you had a clear documentation of your system, and it was this was a requirement for government projects. So any government projects in the UK had to be designed using SSADM. I do enjoy using structured methods, and I will generally use entity relationship diagrams and data flow diagrams where necessary. They are useful tools, but as I've said, they are traditional tools and have been to a certain extent superseded by some other techniques. ERDs are really still quite important for database design, because they describe the relational model, and that is what currently most databases still use. The second approach I've discussed here is object-oriented development, and this is often described as the more modern approach, and arguably it is, but it's not really that modern anymore. It's become pretty standard, and it's been around since the 1960s, so that doesn't really sound very modern to me. It is quite different though. It's based on classes and objects rather than entities in a database, and these days the approach will use models that have been developed in UML, UML being the Unified Modeling Language. UML has been around for a long while, and it's taken a long time for it to become established, but it is now pretty much the standard way of describing systems. So you should actually become familiar with UML if you're not already. Particularly in this case, you should be using class diagrams and activity diagrams and state charts to describe your system. I'll also encourage you to use use case diagrams in order to describe the requirements of your system. Now, whilst these two approaches are quite different and they do result in quite different looking designs, we can apply them equally to information systems. My preference is for an object-oriented development to start with, but be aware that if you do create an object-oriented system, you're going to very likely implement it in a relational database, and therefore you're going to have to convert your class diagram into an entity relationship diagram. So perhaps in reality, if you're using a database and creating an information system, then you'll be using a combination of both structured development and object-oriented development in order to build your system. So my approach would be to start off with use case diagrams in UML and describe the use cases and actors that are going to be in the system. Then, depending on how you're going to implement your system, if you're going to use a relational database, I would then create entity relationship diagrams for each of the use cases and then merge those together to create a final entity relationship diagram. If I'm going to be using an object-oriented database, or I'm just developing it for an object-oriented language, then from the use cases I would actually create class diagrams rather than entity relationship diagrams. So there's a good way of combining those two approaches, and I advise you to have a look at them and make a decision about which ones you want to use. Okay, so just a note on modern systems development, and this doesn't mean you're necessarily going to use this approach, but you should be aware of this and certainly have some idea of this. You're going to be looking for employment after this degree, and I think it's useful in software development to have an understanding of what this means. Modern system development uses an approach called the Agile approach to software development. The Agile approach takes a number of different methods or different techniques or technologies and applies them into the development process. Very much like the spiral model, an Agile method will use increments. Okay, so it will break down the system into a number of increments, and we'll divide those amongst teams, and we'll build those increments separately and just decide on various stages at which the working system will be delivered and which functionality will go into each increment. Agile methods will use an object-oriented approach. Okay, so the structured approach certainly won't be used. Data flow diagrams unlikely to be used, but class diagrams most definitely will. If you're studying UML, then you'll know that there are a large number of diagrams that can be used for systems development. Now, most software development houses will not make use of all of these. They will use class diagrams to describe the classes. They may use activity diagrams to describe their processes, and they may use interaction diagrams to describe the interaction between objects. But often they'll pick and choose the diagrams and the methods that they are used to and familiar with. But the aim of this is to ensure, this Agile method is to ensure that the client receives a system that they want, and that it actually does provide them with functionality. So it's the flexibility and combination of the variety of methods that Agile development uses. It also incorporates a number of project management approaches such as time boxing and stand-up meetings that allow it to move quickly and for everybody in the team to have a clear understanding of where the project's up to. It's not a perfect system, but it is a very useful system, and it does seem to work, and it does seem to be popular among modern software development organisations. So if you get a chance, read any book on Agile software development, have a look at some of the techniques, things like Scrum, time boxing I've already mentioned, stand-up meetings, and incremental development, and you'll get an idea of how this kind of approach works and why people enjoy it. Okay, so which method are you going to choose to complete your project? Largely it depends on you and your personal objectives for your project, and also your project and the type of project that it is. If your project is well understood by you and you have clear and stable requirements, it's something that's been done before and you know that it's achievable, then the waterfall model would probably be okay. although I suspect you'll need to use a variation on the waterfall model. It's very likely that your project is going to have a large number of unknowns, and for example, you may never have used the language before, you may not have developed such a system before. Okay, so there's high risks, lots of unknowns, and the only way to deal with unknowns is to get information about them. And in software development, the best way of gaining information is to actually try building the system. So a prototyping approach actually becomes more suitable. So we have two extremes here. We've got well understood project, clear and stable requirement, minimal amount of risk, follow the waterfall model. High risk, large number of unknowns, lots of new development approaches that we've never tried before, so you'll need to prototype. In reality, your development will probably be somewhere between these two, but bear in mind that you can use prototyping as part of the requirements gathering phase or as part of the design phase, and then the implementation may be fairly straightforward. So remember, you should document your method, explain why you're using your particular method, but make sure that it clearly matches the requirements of your project. Okay, so a couple more possibilities. There may be a number of clearly defined use cases, and we'll talk in more detail about use cases in the next topic. But maybe the timescales for each of these use cases are unclear. Then in that case I would use an incremental approach. So we take all the use cases, prioritize them, decide which ones are the most important, and implement that part of the system. And then for a second increment we might come around and use the second priority use cases, and then we may have a third and a fourth increment. This means that we've actually got an advantage in that we can implement a small system, make sure it works, learn as much as we can about it. If we then have time, we can develop a larger system, a second version of the system. Or if we don't finish the second version, well, at least we've already got one version that works. So this to me is a method that gives us a clear advantage in an academic project. You don't really know how long this is going to take you, so maybe you should divide it up into increments, to develop an increment that you know you're going to achieve within the timescale, and then have as a second increment some work that which can become then topic for further study as part of your write-up. But as I say, the above approach is my preferred approach for a student project, but you've got to choose a project that suits an approach that suits your project. Okay, so we've decided that we know a little bit about the approach to use. We've analysed the project a little bit, and we understand a little bit about how we might need to approach the development. But one thing to bear in mind is to get started, you still need, and you will always need, to establish the functional requirements of the system. Okay, what is the system going to do, and what are the sorts of users that are going to be using the system? So to do this, I always use what I call the use case driven approach. It's actually a very beneficial approach, and it does allow you to establish functional requirements for a system that is larger than the one that you're going to develop. We can actually look at all the possible functional requirements and then make a decision as to which of those we're going to develop for our project. In the development world, if we were doing this work for a client, we would develop a set of use cases and then negotiate with the client as to which ones were core functionality and therefore which ones the client was going to pay for in the first iteration. It might be that the client then decides that they want to pay for additional functionality later. Well, that's fine. We've already built that into the development, so we know what we can do. So incremental development, this kind of incremental development, use case driven approach, actually works quite nicely both for academic projects and for real projects for clients. So a use case, briefly, a use case here is a description of a unit of functionality. Okay, it's the way in which a type of user will use the system in order to achieve a clear goal or an outcome. Okay, so in the campus system, you use campus to view a lecture online. So that would be a unit of functionality. Okay, and that gives a type of user, i.e. a student, and a clear goal. Okay, your goal is to view the lecture, so you click on various links and eventually you'll be able to view a lecture. Okay, so a use case is a description of a unit of functionality, or a way in which a type of user will use the system in order to achieve a clear goal or outcome. And as another example of types of user, I'm a lecturer, so I have different functionality. I can create chat rooms on the campus system, whereas you can join a chat room and just use it. You can't create your own chat rooms. So the type of user will have different functionality, and that functionality may well be limited just to that type of user. So we have to think about the functionality, but also the different types of users that use the system. Okay, and each of our use cases must have a clear goal or outcome. Otherwise, it's not really a use case. Okay, so you need to have a look through the tutorial material for this topic and do the exercises that you've been given. Mostly those exercises will be relating to the waterfall model and other development life cycles. You need to analyse your project and decide which of those life cycles should really be applied to your project. Some of the reference that I've used in this particular lecture, certainly there's the books by Dawson and Weaver. Again, they both have sections dealing with systems development life cycles, so you should have a look through those. And of course there's the link to the Wikipedia discussion on waterfall model. There is plenty of other stuff on Wikipedia, and whilst I don't recommend it for every academic use, the software development work on there and the description of various methodologies is pretty thorough and pretty comprehensive, and you'll come across a number of other approaches to software development that even I don't know exist. Thirdly, I've got a book by Ian Somerville which is called Software Engineering. This is a fairly standard academic text on software engineering, and it's worth having a look through, at least to have a look at the various development methods that I've talked about. There is another software engineering book by a gentleman called Pressman, which is as good as the Somerville book, so you might want to have a look at that one instead, or as well. The more reading you can do, the better informed you'll be. Okay, so that was topic 3. It was a fairly brief discussion of the various development methodologies that you could apply to your project. Now, the important things to remember are that you're choosing a method that fits your project, so really the method that you go through has to be determined by the project requirements. Bear in mind that if you've never done this project before, then it's likely that you're going to use a prototyping approach or something very similar to a prototyping approach. Don't choose a waterfall model if you have high risk and very limited information about what you're going to develop. Okay. On the alternative side, if you are confident about what you're doing, you've done a similar system before, then you can choose the waterfall model or something very similar to it with no problem. But the important thing is, as I've said, make sure that the method you choose does clearly fit the project, and then you should be okay. Thank you for listening, and look forward to speaking to you on the next topic, topic 4, where we will deal with use cases and how we develop them and how we use them for the use case driven approach. If you've got any questions, I'll be available as usual on my early morning chat sessions. Early morning for me, late evening for you probably, and also there'll be discussion on the discussion forums. Please remember to make use of these facilities. They do clearly help clarify some of the thinking that's going on in lectures, and I'm sure I'll look forward to speaking to you on the chat room or in the discussion forums fairly soon.